Okay, folks, we're going to start up in about 1 minute here. We're starting up in about 1 minute. You might want to come back and...
You guys have a good break? All right. Let's rise to our feet. Let's sing a song. Praise Him, all ye sinners. Praise Him, all ye sinners. Oh, sing, ye weary. Praise Him, all ye children of God. We lift high, for we lift high your glory, and will forever adore thee. We'll praise you as the children of God. Great Redeemer, our great Redeemer, glorious Savior, your name is higher than the rising sun. Amen. Light of the morning, you shine forever. Your name is higher than the rising sun. Your name is higher than the rising sun. Praise His name. Praise His name forever. Sing it loud and clear now. Oh, praise Him, all ye children of God. Sing it, church. Our great Redeemer, glorious Savior, your name is higher than the rising sun. Light of the morning, you shine forever. Your name is higher than the rising sun. Your name is higher than the rising sun. Hallelujah, name above all, simply to speak, your name is praised. Hallelujah, now and always, forever we will lift your name. Hallelujah, name above all, simply to speak, your name is praised. Hallelujah, our God you reign, simply to speak, your name is praised. Our great Redeemer, glorious Savior, your name is higher than the rising Beautiful voices, church. Beautiful voices. You may be seated.
Everybody have enough to eat? Make your own tacos. Yum, yum, yum. They're coming. I just heard that our catering department was up at 3 o'clock this morning cooking those. So they better be good. I'm sure they will be. So this is session 2, and we're going to let Jason get started right away. Without further ado, just a reminder, lots of stuff out there to look at. I think you know that already.
Basics of science in different fields to see how it confirms creation. And it really does. It really does. We live in a society where we're taught that science has disproved the Bible from the very beginning. You can't believe in Genesis, and therefore you can't believe in the rest of it either because science proves evolution happened. Well, it really doesn't. It's just that we all have a way of looking at the evidence. We need to recognize that. And the way that we view it, it depends on our worldview, our way of thinking about things. Creationists and evolutionists look at the same fossils and we draw different interpretations about what they mean because we have a different worldview. Secularists, when they're looking at the world, they already have a view of it in mind in terms of, if they don't believe in God, well, the universe has to be an accident, in which case things came about naturally and without any kind of plan or forethought, and they have that in mind when they look at the world. When I look at the world, I have biblical history in mind. I've got the true history of the universe as recorded by eyewitnesses and ultimately inspired by the Holy Spirit, so there's no error in it at all. And when I look at the world, I think of biblical history and I interpret the evidence accordingly. We can't travel back in time and scientifically test creation versus evolution the way we test things like gravity or the motion of the planets, things we can observe today. But we can take a look at the science today and see if it matches the expectations, what we'd expect if creation's true versus if evolution were true. And we're going to find it's very consistent with creation. And we're going to look briefly at 3 different fields of science today. We're going to look at genetics, which is the study of how traits are passed on from one organism to the next. We're going to look at information theory, which maybe you've never heard of, but it's powerful evidence of biblical creation. And then we'll look at geology, things like rocks and fossils as well. And we'll see that they confirm biblical creation. So let's start with heredity, the study of how traits are passed on from one organism to the next generation. And we're going to start with dogs because we can see how dogs reproduce and so on, and they do so quickly. So my first question is, do dogs change from one generation to the next? Do dogs change? Yeah, dogs change into other dogs, right? Yeah. You can get all these different breeds. And we understand genetically how that works, and we'll talk about that today. And we would expect this because it's what the Bible tells us. The Bible tells us that God created animals after their kinds, or after its kind. That phrase is repeated 10 times in Genesis 1. We better take it seriously. Now, a kind is not the same as a species, and we got to be careful about this. Some creationists make that mistake. They say, well, you can't get different species. Well, you can get different species, but they're still the same kind, okay? So like a group of mosquitoes goes off and lives in a cave for 100 years, and due to genetic drift, when they're brought back out, they can't interbreed with other mosquitoes, and so they're classified as a new species. That can happen. They're still mosquitoes. They've always been mosquitoes, and unfortunately, they always will be mosquitoes, right? And it's the same with dogs and everything else. See, there's a misrepresentation of what creationists teach that sometimes evolutionists propagate this. They'll say, well, creationists believe that God created all the animals as we see them today, and in some versions in the same locations they are today. That is not what we believe. That's not what the Bible teaches. Okay, so this is a misrepresentation of what creationists teach. The reality is more like this. Animals have diversified over time. God has built within them the ability to do that, but they remain the same kinds. Dogs have always been dogs. They're dogs now, and they always will be dogs. But you can get lots of variation. You can get lots of different breeds, and we'll see how that works. Okay? And so, and of course, some kinds have gone extinct. Some varieties have gone extinct where other varieties of the same kind remain, like elephants. We think mammoths are related to elephants. They're the same kind, we believe. Okay? It's just that one variation is gone and the other remains. Then there are some kinds like the dinosaurs that they've been wiped out completely, and as far as we know. And so basically that's how that happens. So the animals we have today are not identical to the kinds that they are not identical to the varieties that existed at creation, but they're the same kinds. Okay? I don't believe that there were poodles in the Garden of Eden. right? It was a paradise. You're not going to have poodles in it. Okay. Whereas in the evolutionary view, everything's related to everything else in the evolutionary view. And so there really aren't kinds in the evolutionary view. There's one kind. Everything's related to everything else. I reject that, but nonetheless, that's what they would teach. And so to see which of these views is consistent with the evidence today, we need to talk about DNA. This is a long molecule that occurs in the cells of your body. It looks like a twisted ladder. And on the rungs of this ladder are what we call nucleotide base pairs. And there's 4 different varieties. And they're abbreviated by the 4 letters you see there, C, T, G, and A. Okay? And the C's and G's always line up, and the A's and the T's always line up. But on a given strand, you don't know which letter is going to come next. Could be a C, could be a T, could be an A, could be a G, you don't know. Okay? And based on the order of those, it spells out the instructions to make the proteins that make up you. It's pretty remarkable. And so in the same way you could spell out help with beads on a rope, you could spell out the instructions to make you on a molecule, which is amazing. I mean, we think we're clever. We can get all this information on a Blu-ray, and that is impressive. But God put the instructions to make you on a molecule. Pretty neat. And you've got about 3 billion instructions, 3 billion base pairs, times 2, because you have 2 sets of DNA. And the reason that you are a person and not a cabbage is you have the instructions to make a person, and a cabbage has the instructions to make a cabbage, okay? And some of those instructions are the same because we use some of the same proteins, which is why you can eat cabbage and gain nutrients from it. So you have 2 sets of DNA. You get each little bit of information from one parent and from the other parent. So your parents, they had 2 sets of DNA and so on, all the way back to Adam and Eve. They had 2 sets of DNA they got from God. And the children, you don't know which of the 2 genes you're going to get. A gene is a section of DNA that controls a trait. Okay? And so the first child might get that gene from dad and that gene from mom, and so they have a new combination, you see. And that's why they don't look exactly like either of their parents, but they look a little bit like both, because they got the information they got. They have 2 sets of DNA, and each gene comes from one parent, on each set. And so the next child's going to look a little different, though, because they get a different set, you see. They still get all the information from their parents, but you have a unique combination, unless you have an identical twin. You have a unique combination of DNA. And so you might look a little like dad, a little like mom, and you might have some traits that neither has because you have a unique combination. It's the combination of those traits, it's the combination of those genes that determines your traits. Here it is with blood type. With blood type, there are 3 possible genes. We call them alleles: A, B, and O. A and B are dominant, O is recessive. So a dominant, it'll take over the other one, right? So if your blood type's A, you have one of these combinations. It can be A from dad, A from mom, your blood type's A. You get A from dad and O from mom, your blood type's still A, because A is dominant, O is recessive. Maybe you remember doing this in school. There it is with blood type B. There's the different combinations. Now A and B are co-dominant, so if you have A and B, your blood type's AB. The only way you can have blood type O is to have both O alleles, because it's recessive. Okay, so you see how that works? So there it is with blood type. Now, the interesting thing is if mom has blood type A, and it's what we call the heterozygous A, where you have A and an O, and if dad has blood type B, and it's the heterozygous B, where you have O and B, then the children can have any possible blood type, right? Because the first child could get the A from mom and the O from dad, their blood type's A. The next one could get the B from dad, the O from mom, their blood type's B. They could have A from mom, B from dad, their blood type's AB. So they could get O from mom, O from dad, their blood type's O. You see? And so it's interesting. So if mom might have blood type A, dad might have blood type B, you could have blood type O. That's possible. That's how it works. And that's the same with all our traits. All our traits are determined by combinations of genes. Now this is simplified, but you get the idea. Here it is with skin color, again simplified, but this is basically how you do it. We all have the same skin color, brown. It's just a question of how much. There's a pigment called melanin. There's a couple different forms of it. And if you have these kind of genes up here, you'll have a lot of melanin. It'll be widely distributed in your cells. You'll be very dark complected. If you're down in this box, then you have the very light skin color. But if somebody in this box gets married to somebody in that box, their kids will be in that box. Because that's the only combination is with the lowercase letters, you see. That's the only combination that's possible. You get locked in to that. And everywhere along this diagonal, if you get married to somebody in the same box, your kids will be in that box because those are the only combinations that are possible Okay, and so there's a loss of what we call heterozygosity. But if you're in this box and you get married to somebody in that box, your kids could be in any one of the boxes, you see. And we think Adam and Eve probably had a middle brown skin color. There's other ways you could do it. But yeah, and so their kids could have been anything from very dark to very light. And there's still places in the world where this happens today, where you have a lot of that heterozygosity. Certain places in India where at the same dinner table, somebody's very light, somebody's very dark, because their parents are in one of those categories. So that's how that works. We're going to take a look at how dogs reproduce, because there's a lot of variation built into the dog kind, and they reproduce kind of quickly. Their lifespans are shorter than ours and so on, so we can see how that happens. But that's how you get the different variations within dogs. It's just the different combinations of genes that God put in the original dog kind. Now the thing that's important to understand about this is bacteria, they've got some instructions in their DNA. They've got DNA like we do, but they've got the instructions to make bacteria. And that's why they become bacteria, you see. A horse has a lot more instructions. It's not just that it has more DNA, which it does, but it has information that the bacteria lack. A horse has information in its DNA to make bones. Bacteria don't have that. A horse has information to make eyeballs. Bacteria don't have that. A horse has information to make ears and feet and so on. And bacteria lack those, so they can't produce those traits. Okay, so the horse has a lot more instructions, a lot more information in its DNA than bacteria, which means if evolution's true and bacteria became horses over the generations as they reproduced, then at some point they had to gain information. That would have to be the case, wouldn't it? If horses are descended from bacteria or something like bacteria, which is what evolutionists believe, then at some point they had to gain brand new information in their DNA. And that's interesting because the processes we observe decrease information in the DNA, and therefore they cannot drive evolution. One of those processes is natural selection. You've heard about natural selection. Darwin tried to convince people that if natural selection is true, evolution is true. But they're not. They're different issues. Natural selection is true, and it's not evolution, and it can't possibly lead to evolution, and I'm going to show you why. So natural selection, it's a creationist concept, actually. Darwin kind of hijacked it. Here's how it works. So you have dogs. Let's say that you have a dog that has a gene for short fur and another gene for long fur, and suppose those genes have a combined effect, and so you have medium length fur. Now, this is simplified, but the basic genetic principles here are accurate. And another dog comes along of the same genetic combination, and they fall in love, and they have pups. Some of the pups are going to get the short gene from mom and the short gene from dad, and they'll have short fur. Some of the dogs are going to get the short gene from one parent, the long gene from the other, and they'll have medium length fur just like their parents. Statistically, 50% of the offspring would get that combination. Okay? And then some will get the long gene from mom and the long gene from dad, and they will have very long fur. Okay, so in one generation you can get different variations. Okay, now this is a great example of variation within a kind. They started out dogs, they ended up dogs. That's not evolution, that's just dogs, right? We haven't gained any new information. We started out with information for short and long and by combination medium, and we ended up with dogs that had short, long, and by combination medium. There's been no gain in instructions, right? Okay, so how does natural selection work then? Well, let's suppose it gets very cold. Now what's going to happen? Well, the dogs that have the longer fur, they're going to be okay, but the dogs that have the shorter fur, they don't like that cold climate, and so sadly they die. Now that's an extreme case. Maybe they just have to spend most of their time in shelter, and so they never meet other dogs because they have to spend their time trying to stay warm, whereas the dogs that have the long fur, they're well insulated against that cold, and they find other dogs that are well insulated against cold, and they reproduce. And what kind of so if you have a long-furred dog that reproduces with a long-furred dog, you're going to get long-furred dog. Yeah, that's how that works, because that's the only genetic combination that's now possible. See, the other dogs are not going to reproduce because they're dead, all right? Or they didn't find each other because they have to spend most of their time inside in shelter. And so the environment got cold, and lo and behold, the dogs that ended up surviving and reproducing in that environment had the long fur, right? Because if they didn't, they wouldn't have been able to survive and thrive in that particular environment. Now, if we started the experiment over again and we have all three varieties, And this time, let's say the environment gets very hot. Now what happens? Well, the dogs that have the longer fur, they don't do well in that hot environment. So sadly, they die, okay? But the dogs that have the shorter fur, they're able to find, and again, this is an extreme case. Maybe the dogs that have the longer fur, they just need to spend most of their time finding shade, and so they're not able to go on and reproduce because they don't have the time. The dogs that thrive in that environment, they're able to find other dogs that have also survived because they have the short fur, and they reproduce, and the dogs they reproduce will have the short fur because that's the only genes that are left. And so, I mean, it's interesting here. So in this case, the environment got warm, and the dogs that ended up thriving in that environment had the short fur. Because if they didn't, they wouldn't have thrived in that environment. So we say the dogs adapted to their environment. That's one type of adaptation. There's different types. That's one type. And so, but is this evolution? Well, hardly. We started with dogs. We ended up with dogs. No evolution there. And we started with information for long, short, and by combination medium. And we ended up with just information for short. You see, natural selection, at best, it can only reduce the information in the genome. That's the opposite of evolution. Remember, to get those single-celled organisms to turn into a horse, you have to add new instructions, new information. Natural selection is not going to do that. That just refers to the removal of the information that produced traits that were not conducive to survival in a given environment. Okay, so there's no new information here. It's just the original information God planted into the dogs, and then whether or not that aided in survival in a particular environment. So this is how we account for the different dogs in the natural world. We do find dogs that end up in cold climates, they have the longer fur. If they didn't, they wouldn't have been able to survive, or at least been able to find each other because they have to spend all their time in shelter. The dogs that end up in the hotter climates, sure enough, they have shorter, thinner fur. No doubts there. And so this is how we account for the dogs that we see in the world. And all those started out from 2 dogs that were on Noah's Ark. That's all you need, 2 dogs on Noah's Ark, and they spread out from the mountains of Ararat, and they take certain traits with them. And if those traits are conducive to survival in a particular environment, then they're propagated. And if not, then they're eliminated. And then there's some traits that are sort of neutral, like eye color. And so dogs have different eye colors. And it's just a question of what traits they happen to take with them in that group. And it doesn't really affect survival too much. So that's genetic drift. So this is how we account for the different wild dogs that we find in the world. It's just the combinations of genes. All that information was in the original dog kind. All that information was in the 2 dogs on Noah's Ark. And some of it's been eliminated over time as it produced traits that were not conducive to survival in a particular environment. But we find dogs are well suited to the environment in which they live, or they wouldn't live there. Now, Darwinists would say, oh, but Dr. Lisle, it's not just natural selection, it's natural selection and mutations. So we got to talk about mutations. A mutation basically is a mistake in your DNA. Think of it as a typo in your DNA. And it can happen when the DNA is being copied. It can be a copying mistake. And so let's suppose you have dogs that have genes for the information to make 4 normal legs, which all dogs should have that information. That's not variable. But there's some instructions that are lost. And so you have an offspring because there's damage in its DNA. It's got some typos in its DNA, and so its legs don't form properly because he's missing some instructions, okay? And so a mutation basically is a loss of information. You're losing some instructions that cause the dog to have 4 normal legs, and so his legs don't form quite properly, and so he ends up with short, stubby little legs. And if you think about it, a dog like that is not going to do so well in the wild, is he? He's got those short, stubby little legs. He can't run very fast. He can't catch anything. He's more likely to be caught by something else, okay? He's not going to do well in the wild. And so we find that in nature, mutations are somewhat reduced. They're held at bay because they tend to produce damaged features, and that doesn't help the organism survive. And so they're weeded out to some extent in nature. But some people like dogs with short, stubby little legs because they can't jump up on you as much. And so people will take these little guys and they will care for them. And this guy doesn't have to survive in the wild. He's got a human caretaker that takes care of all his needs and spends millions of dollars trying to keep him alive, okay? And people will take dogs with short, stubby little legs and breed them with other dogs with short, stubby little legs, and you end up with lots of dogs with short, stubby little legs. And so domestic breeds of dogs tend to be full of mutations. And many of them could not survive in the wild, but they don't have to because they have a human caretaker who takes care of all their needs. There's a mutation that causes a dog's snout not to form properly. A dog's supposed to have a long snout, and that helps with their ability to smell and so on. There's a mutation that causes the snout to be short, but the jaw was designed to fit the longer snout, so they have a horrible underbite. And then the skin was designed to fit the longer snout, so it hangs off the side, and if you don't clean it, it can get infected. And some people think that's cute, but you think the dog says, gee, I love having my nose stuffed into my face. That's great. It might not be so pleasant for him. Domestic dogs have all kinds of problems because of that. Poodles, for example. Poodles have some problems. They really do. They're cute, but they have some problems. And these are some of the issues that they can have, either as a result of a mutation or as a secondary result. For example, there's a gene that regulates fur growth. We talked about that, short or long fur, right? In a poodle, that gene has been damaged, and they cannot regulate their hair growth. With poodle, their hair grows forever. And if you don't, so every now and then you have to get your poodle a haircut. Now that dog could not survive in the wild. You will never see a Discovery documentary about the wild poodle, right? Stalking his prey. No, you won't see that. They need humans or they would be extinct, because that, in the wild, trying to drag all that hair behind it's not going to work. They need a haircut every now and then. If you don't get in their eyes can get infected. They can go blind. Poodles are very prone to that. Or they can get in their ears. Their ears can get infected. It can kill them. And so it's a problem. But yeah, so domestic breeds of dogs, and not just poodles, but all domestic breeds of dogs tend to have a lot of mutations. They have problems because nature is not weeding them out, because humans are taking care of them. And so we have artificial selection instead of natural selection. And that tends not to eliminate mutations. So this is how we account for the different domestic breeds of dogs. It's the genes that God planted and mutations, mistakes that have crept in, that have eliminated some of that information. Okay? But it's not evolution, though, because we started with dogs and we ended up with dogs, sort of. And but there's been no increase in information. It's actually been a loss of information. Okay? And so you get down to the poodle, and that's kind of it, right? Because he's lost some instructions. In the case of the poodle, quite a bit, because he can't regulate his hair growth, for example. When I'm explaining this to youngsters, I say it's kind of like jelly beans. You get the wild kinds of dogs, lots of jelly beans, lots of information in your DNA, and then as you selectively inbreed them, you get a reduction of information until you get down to the poodle, and then that's kind of it. It's the bottom line, right? You can think of if you think of it in terms of cars, you got like the wild kinds of dogs would be like the Rolls Royce, where it's got all these extra features on it that are not essential. Windshield wipers on the headlights, that's cute, but you could live without it, right? Whereas the poodle is more like a Kia. It's kind of, you remove one part on a Kia, it doesn't work anymore, because it's the bare minimum that you can have for a car. So that's kind of the way it is. Now, could you ever turn a dog into a cat by removing jelly beans, by removing information? The answer is no, because they have different information. They got Jolly Ranchers instead of jelly beans, okay? So, now again, some of the instructions are the same, and that's necessary because we use some of the same proteins, right? In order for us to eat a banana and gain nutrients from it, it has to have some of the same proteins we use, and therefore some of the DNA will be the same. There's no doubt about that. If God had made totally, because sometimes evolutionists will say, well, then why do we have similarities in our DNA to a banana? Because God wanted us to eat bananas and other things, right? If we had totally unique DNA, if all life forms had totally unique DNA, the only thing we could eat would be each other. That would be a problem, okay? So we don't want to do that. So you see, it's really consistent with biblical creation, isn't it? We find that when dogs reproduce, they reproduce dogs. Now, this is something we can test in the present. It's good observational science. It's consistent with what the Bible teaches, with God having created the original dog kinds and put information in them to be able to diversify into the different breeds that we have today. It does not confirm the evolutionary view, where you would have information increasing over time. We do not see that. We do not see that happening. Now, I do have to point out, because evolutionists mention this, that mutations can be beneficial by losing information. There are certain situations where a mutation can actually help you survive. That can happen. One example I'm going to give is antibiotic resistance. And the key here is that, yes, mutation can help you to survive, but it's by losing information, and so it's in the opposite direction of evolution. So antibiotic resistance, for example, there's a bacterium called H. pylori, which causes stomach ulcers, and that's unpleasant. So you go to your doctor, and he gives you an antibiotic. The antibiotic, which is harmless to you, goes into the bacterium, and he's got an enzyme that's just part of his internal system that when it reacts with that antibiotic, it converts it to a poison. And the poison kills the bacterium, and you feel better until you get your medical bill. There is a mutated form of H. pylori that lacks the ability to produce that enzyme because he's got a mutation. He's missing some instructions, or at least he can't produce very much of it. And so the antibiotic goes into him, and it just sits there because he lacks the ability to convert it into a poison. And so he survives, but he survives because he's missing some information. And that happens. We know of bacteria that become resistant to antibiotics in hospitals. That happens. They're the only ones that survive because all their cousins have been killed off by the antibiotics. But is this a new and improved life form? And the answer is no. He's lost some instructions. He's never going to turn into a horse that way, because to turn into a horse, you'd need to add instructions, you see. And that's why you need to take all of your antibiotic even after you feel better, because when you start to feel better, you've killed off all the normal ones, and the mutated ones are the only ones that are left. And if you go off your antibiotic, they'll reproduce, and then now you have a resistant strain, and they're harder to kill then. You want to finish your dosage, because eventually it'll kill them too. They do have a little bit of that enzyme in them. It just takes a much larger dosage to kill them off. But the point is, it's not evolution. This is an example of adaptation, certainly, because they've adapted to their environment. And it's an example of mutations, it's an example of natural selection, but it's not an example of evolution because there's been no new information added. And that's what you would need, among other things, to get evolution to work. Dr. Lee Spetner, PhD, Johns Hopkins University, says all point mutations that have been studied on a molecular level turn out to reduce the genetic information, not to increase it. Not even one mutation has been observed that adds a little information to the genome. Now, see, if evolution is true, we're made up of information-increasing mutations, right? Because our ancient ancestors were microbes like bacteria. And so somehow we gained all of our information via mutations, and then those that were not eliminated by natural selection. But we don't observe that. Evolution is not something we observe. So you see, when we study genetics and we apply observational science, we find that, hey, information can be lost, but it's never gained. We don't gain brand new instructions in our DNA. That's consistent with what we'd expect given what the Bible teaches, that God created the original kinds, planted the information in them, and then as they reproduced, we see the variations come out, but they remain the same kind. It's not consistent with evolution. Well, we've been talking about information, but we probably ought to define our terms, because there's actually a branch of science, information theory. It deals with information, how it's transmitted, and so on. And information always entails, three quantities, because we sort of have a feel for what information is. When you pick up a book, it's got information in it. But how do we define that? Three criteria. This is one way we could define information, by these three criteria. First of all, it involves a symbolic code system. And so when you pick up a book and you open it up and you see the word horse, you do not see an actual horse. You see a word that represents the animal, right? And so that's a code system. And in this case, English, it's letters and words and so on. So there's a symbolic code system. That word represents, in this case, an animal. There's a language. The books that we read are organized into words, which are organized into sentences, which are organized into paragraphs, and so on. And so there's a flow of thought. And there are rules of grammar and so on. And so, yeah, that's information. And then there is meaning. I can learn something when I read this. There's an expected action on the part of the recipient, and there's an intended purpose. There's a reason why somebody wrote the book, and there's something you're supposed to do as a result of reading that book. If it's a cookbook, for example, the expected action is that you will combine the ingredients in the way the book says, right? A cookbook has all these criteria. It's got a symbolic code system. Mix 3 teaspoons of sugar with whatever. You don't see the sugar, you see a word that represents the idea. It's organized into sentences, that's language. The expected action is that you will combine the ingredients in the way the book says, and the purpose is so that you won't go hungry. So it fulfills all those criteria, all right? So let's test our information detection skills. You got those three criteria: symbolic code system, language, meaning. Could this be information? Could be. It looks like there's a symbolic code system there. Is there language? It looks like it's organized into sentences. Is there meaning? That's the tricky one. And in order to figure out that last one, you have to know what the symbols mean. But the good news is I know what these symbols mean. And this is information. It's actually Genesis 1 through 5 in the form of icons. Right? In the beginning, like the movie clipboard, right? In the beginning, God created the heaven and the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God was hovering over the waters. And God said, let there be light. And there was light. And God saw the light, that it was good. You see that? Isn't that neat? So there is information there because it's got a code system, it's got a language, and it's got meaning. It's telling us how the universe was created. And so, yeah. Now, once you have established that you have information, there are certain laws of nature that apply to that. Just like when you have energy, there are laws of nature that apply to energy. There's the first and second law of thermodynamics, for example. The first law says that energy can't be created nor destroyed. It can only be transformed. And so that law applies to energy. There are laws that apply to information. One of them is that it doesn't generate itself. Dr. Werner Gett, one of the world's experts on information theory, says there is no known law of nature, no known process, and no known sequence of events which can cause information to originate by itself in matter. Interesting. So information doesn't just generate itself. If you have a box of alphabet soup and you mix it up, don't expect to get Shakespeare. We know that. We know that. Where does it come from then? Where does information come from? He says when its progress along the chain of transmission events is traced backwards, every piece of information leads to a mental source, the mind of the sender. Information is the product of a mind, always. There are no known exceptions to this. So if you read a book and it's got creative information in it, somebody wrote it. It comes from a mind. Now, they may not have written that copy. That might have been made by a machine that makes a lot of books simultaneously, okay? And it probably got its information from a computer, and it got its information from another computer. You can trace those transmission events backwards, and eventually you'll get to a mind, though. Somebody wrote it, if it's got creative information in it. There are no known exceptions to this. We know that. You pick up a book, you wouldn't conclude, well, this probably happened by an explosion in the typewriter. You know that somebody wrote it, the original. It may have been, now inanimate machines, mindless machines like a Xerox machine can copy information, but they cannot produce it. Xerox machines can copy books, they can't write them, right? Now that's interesting because what do we find in DNA? Information. Information to make you. Where did you get your information in your DNA? You got it from your parents. It was copied by a non-mental process. The chemicals in your cells, they're designed to be able to copy DNA. Okay, so you got it from your parents, they got it from their parents, they got it from their parents, all the way back to Adam and Eve, who got it from the mind of God. You see, genetics, what we understand about genetics is consistent with information theory if it's a creation-based view of genetics. But in the secular view, the information in our DNA has been the result of mutations, which are non-mental. That violates the laws of information theory, you see. So information theory is consistent with the creationist view of DNA and the information within it. It's not consistent with the evolutionary view. And I think it's interesting because in all other respects, secularists would admit that if you find information, there's a mind there. I did a social experiment a number of years ago. I posted an article called On the Origin of Articles. And the article is supposed to convince you that articles do not have authors. The article explains that articles are actually a process of evolution. They probably started out as a single letter, and then as they're copied, mistakes are made. And granted, most of those mistakes make the article worse, but every now and then a mistake makes the article better, and those are preserved and passed on. And so articles become longer and more interesting over time. They don't come from authors, right? And it was a cute article, and it was one of my first attempts at satire, and I think a pretty successful one. But the really funny thing was the responses that I got to it. Because evolutionists would get on there and they'd say, "This is stupid. We know you wrote this, Dr. Lisle." I would say, "How? Did you see me write it?" "Oh, you're taking it on faith? That's interesting." "Oh." "Well, we could check your IP address and show that you posted it." "Hey, I admit to posting it. When this thing evolved on my computer, I couldn't help but share it. It was too good," right? And it was funny, they kept arguing with me, and I'd play the part of an evolutionist. You know, I'd say, "You must be one of those authorists that believes in authors." In fact, if there's an author to this article, let him show himself right now, and then I'll believe. Which was comical to challenge myself that way, but you know, it was so funny to argue with him. Well, you know, we know you wrote it. How do you know that? How do you know that? I mean, if you believe that, that's fine, but man, keep that in church. I don't want to hear about it, right? Now, they very easily could have established that I or someone wrote the article. All they'd have to do is point out what has information in it, and therefore it came from a mind. Not one of them tried that. You know why? Because then they'd have to admit evolution is false. They would rather be absurd than give up evolution. And you know, the Bible tells us that. The Bible tells us that people would rather be reduced to foolishness than submit to the Holy God. We need the Holy Spirit to overcome that. So anyway, let's move on and talk about geology now. Geology, the study of rocks and fossils that are found within them. That would be paleontology. But there's this myth that we need to blow up, first of all, because there is this myth that we know that rocks are billions of years old because of radiometric dating, okay? And so the idea, you know, and people don't really know what that involves. They think it's almost like magic, you know, you pick up a rock, you scan it with your tricorder, and you measure the agicals, and it tells you the age of it. That's not how it works, okay? I want to show you how radiometric dating is supposed to work and why it really doesn't give the age of anything. So there are certain atoms, we know about atoms, you got protons and neutrons in the nucleus and electrons orbiting around. There are certain atoms that are unstable or radioactive. And basically what that means is they would really rather be a different type of atom, and they will spontaneously change into another atom by either ejecting protons and neutrons or ejecting an electron or a positron. So for example, uranium-238 is unstable. Uranium-238 will spontaneously change into thorium-234. It'll eject an alpha particle, 2 protons, 2 neutrons. You don't have to do anything to it. It does it all by itself. Chunk of uranium-238, it's constantly, the atoms are constantly popping and changing into thorium. And it's also unstable, so it'll change into the next element, which changes to the next one, all the way down to lead-206, and then it stops because lead-206 is stable. It's not radioactive. So once you get to lead-206, it'll stay that way forever. And again, you don't have to do anything to it. It happens all by itself, atom by atom. And it's kind of like popcorn. You don't know which kernel is going to pop next. You don't know which atom is going to change uranium-238 into thorium. But with your popcorn, you do know that after about 2 minutes, it's all done, right? If they're going to pop, they've popped. And it's the same way with this. You don't know which atom is going to pop next, but statistically, we do know that after a certain amount of time, a certain number of those atoms will have decayed into these other ones. Okay, that's how it works. And so the bottom line is if I had a chunk of solid uranium, and I just held it there, after a while it would be part uranium, part lead, part intermediate elements, which I've not represented here for simplicity. If I waited long enough, it would eventually all be lead. Okay? And we know the rate at which this happens because we can measure, you know, over a year we can say, oh, this, you know, 0.0001% of the uranium has changed into lead. Okay? And we can extrapolate that. And so the idea is if you have a rock that has some uranium and some lead in it, we know the rate at which the uranium changes to lead. You might think, well, we could extrapolate back and figure out when it was all uranium because we know the rate. That's true. But here's the problem. How do you know the rock was all uranium to begin with? How do you know somebody didn't make it yesterday and it already had a lot of lead in it? And by the way, secularists do not assume that the rock was all uranium. They assume it had some lead in it to begin with. But how much lead? You tell me how old you want the rock to be, I'll tell you how much lead it started with. You see the problem there? There is a problem there. And secularists are aware of this. Don't get me, they're not stupid. And they've got ways to try and estimate the initial elements. But the fact is you don't really know. You don't really know the initial elements ratio. So you can think of the uranium changing into lead like sand going from the top chamber to the bottom chamber in an hourglass. Uranium becomes lead, or potassium becomes argon, and so on. And you can use that to measure time if you know the initial elements, if you know the initial ratio. If I had an hourglass and it looked like that, when you came into this room, you said, how long ago do you think I turned that over? You said, what's an hourglass? Looks like it's about halfway done, half an hour. I'd say, you're way off. I turned it over 1 minute ago, but already a lot of the sand was in the bottom chamber. So you can't assume all the sand is in the top chamber. That's one of the assumptions of radiometric dating. is that you know the initial ratio of parent to daughter element. The other is that how do you know that somebody didn't add sand when you weren't looking? Uranium is leachable in salt water. It can move in and out of the rock. That's a problem. How do you know the throat of the bottle's always been the same size? Maybe the sand fell through faster in the past. That's probably a pretty safe assumption for an hourglass, but we don't know what keeps radiometric dating constant, and therefore it might not have always been constant. And there's good evidence that it's not always constant. There are certain elements, certain radioactive elements, where we've been able to speed them up in a laboratory by a factor of 1 billion. We can make them decay 1 billion times faster. The rhenium-osmium reaction, we've been able to speed it up by a factor of 1 billion just by ionizing the atom, which is pretty easy to do. So bottom line is these are some of the assumptions of radiometric dating, okay? And we know that one or more of these is wrong because we've tested radiometric dating on rocks whose age we know. When Mount St. Helens erupted, it produced brand new rocks. And that's when they form from the magma, that's when they solidify, that's supposed to set the 0 point on the clock. Because before that, it's liquid. The elements can move in and out. So initially, this happened back in 1980. There have been some subsequent eruptions. And we created brand new rocks. We sent them in and had them dated, which normally would be stupid because it's expensive to date rocks and we already know their age. But we wanted to test the method. We sent them into a secular lab so we couldn't be accused of bias. And they came back with ages of hundreds of thousands of years on rocks that we know are brand new. Radiometric dating has been shown to not work on rocks of known age. Secularists assume it works on rocks of unknown age. I don't think that's logical. It'd be like if I gave you a calculator and you put 2 plus 2 equals and they gave you 57,212. You say, I don't think I trust this calculator. I said, don't worry, it works on big numbers. Well, if it doesn't work where I can check it, why should I trust it where I can't check it? There's carbon dating. A lot of people have the misimpression that carbon dating is what gives the millions of years. It doesn't. Carbon dating is our friend, and it tends to be more reliable. Now, it's not perfect either. Carbon dating can be fooled as well. But when we check it on things of known age, it tends to give the right answer within a factor of 10 or so. It's reasonable. And it works because there's a certain type of carbon called C14. Most carbon's C12. There's a variety that has 2 extra neutrons, C14, which makes it unstable. C12, stable. C14 will decay into nitrogen. And it's produced in the upper atmosphere when cosmic rays bombard nitrogen. They convert nitrogen into C14. And C14 wants to decay back into nitrogen. And when you're alive, you are eating plants. Plants take in the carbon dioxide. 1 atom in a trillion is C14. So 1 atom in a trillion in plants is C14. They build themselves from that carbon. You eat the plants, or animals eat the plants and you eat the animals, and you get that C14 in you. So a small fraction of you is C14. You're all slightly unstable. How about that? Okay? And it's always decaying back into nitrogen, but when you're alive, you're replacing it because you're eating food, you're breathing, right? Then when you die, you're not eating food anymore, you're not breathing, so the C14 decays away. So the C14 when you're alive stays about the same. And then when you die, it decays away. And if things were millions of years old, there'd be 0 C14 in them. Because the half-life of C14 is 5,700 years. It can't last millions of years. You find anything that's got C14 in it, it's not millions of years old. It's much younger than that. And the ironic thing is we find it in pretty much everything. Anything that has carbon in it, a lot of these fossil remains, sometimes there's carbon left in them. You can carbon date them. You get thousands of years. Dinosaur fossils, everyone we've dated gets thousands of years. Everyone. Diamonds that secularists believe to be 1 to 2 billion years old, we've carbon dated them. You get thousands of years. They have C14 in them. Everyone we've checked. Chunks of coal, they have C14 in them. They said, well, that's contamination. Well, then we tried diamonds, and they have C14 in them. That's contamination. It's somehow getting in there. How? It's a diamond. It's the hardest substance. How are you going to get new C14 in there? That's a problem. There are lots of things like that. The rate at which salt flows into the ocean, even fresh water has a little salt in it, picks it up from the land, deposits it in the ocean. The water evaporates, that leaves the salt, so the oceans actually get slightly saltier every year. We can measure that. The rate, 450 million tons of new salt enters the ocean every year. You can get rid of a little bit of it with salt sprays, but most of it just accumulates. You run it back, even being very generous to the critics, you can't go more than 62 million years because then there would have been no salt. right? And that's an upper limit because you can't have less salt than no salt, right? So the true age would be less than that because we think the oceans were salty when they were created. But it's interesting because the secular age of the ocean, 3 billion years. Biblical age, 6,000 years. And yet the evidence indicates it can't be more than 62 million as an upper limit. Now the Bible's consistent. It's lower than that upper limit, so that works. But the secular view does not. Likewise, the rate at which mud accumulates on the ocean floor, that can't last billions of years. It takes 12 million years at current rates, and that's ignoring a worldwide flood, which would dump a lot of mud quickly. Human population, how long does it take to get Earth's current population of human beings? It doesn't take anywhere near millions of years. It's a few thousand years. But the best evidence for a young Earth is we have the birth certificate of the universe. That's what the Bible is. And that's the best evidence we have, because that's eyewitnesses, and it's not just any eyewitness. We have God himself declaring that he made in 6 days. So the secular scientists like to say the Earth's billions of years old. Take my word for it. But God says I created in 6 days. Take my word for it. But the evidence is consistent. What about these fossils that we find? There's evidence that they formed quickly. I was always given the impression that fossils take millions of years to form. Here's a fossil ichthyosaur. It's a marine reptile now thought to be extinct. And this thing was killed, buried, and fossilized in the process of giving birth. You see the baby ichthyosaur being born there? They're born tail first because they're air breathers. So as soon as they're born, they have to swim to the surface and get their first breath of air. Wonder how evolution accomplished that. How many millions of years it took to turn that thing around so that, how many failed cases where it came out head first and then they, suffocated. See, it's got to be designed that way from the beginning or it doesn't work. People think that, fossils just sort of happen over millions of years, but we know that doesn't happen. And we could do a hypothetical experiment on our dead cat Earl and watch him slowly fossilize over millions of years, right? So what happens? Well, day 1, you got a dead cat. On day 3, you got a smelly dead cat. On day 9, you got a very smelly dead cat. On day 20, parts of Earl are missing. On day 38, more of Earl is missing, and then by day 65, Earl's missing. And we know that. You've seen animals that have been killed and left on the side of the road. They don't slowly turn into statues over millions of years. They're eliminated. They're picked off by scavengers. They're recycled back into the environment. They decay. If you want to form a fossil, you have to bury something to protect it from the elements. And even then, I was given the wrong impression. I was told the fish dies, it sinks down to the bottom, and then over millions of years, it's covered up with sediment. Now, wait a minute. If it took 1 million years to deposit that layer of sediment, the top part of the fish would have had plenty of time to decay away, right? You got to bury the whole thing, and you got to do it fast. Most fish float too when they die, so that's not how you account for fossil fish. If you really want to make a fossil fish, here's how you do it. You go home to your aquarium, and there's your little fish there, oblivious to what's about to happen to him, and you dump some concrete in there, okay? Yeah. And that's going to kill him. That's going to bury him, right? I don't know about here, but this is still legal in Colorado, so there we go. And usually there's enough bacteria left in there they can eat away at the soft parts of the fish, but the bones remain. And they permineralize. The minerals in the water will move in and fill in all the holes in the bone. Bones are porous and they're light. Fossils are heavy because it's basically bone that's become stone because it's accumulated those minerals. That's how you make a fossil fish. We know we can do this. We can do it in a matter of days. It doesn't take millions of years. What about the kinds of fossils we find? Do they indicate evolution? You'll see things like this in the textbooks, and that looks pretty convincing until you realize, wait a minute, what I'm seeing here are different varieties of horse. You say, but their feet are a little different. Okay, that's one of the variations that God built into the horse kind. The kind that had the 3 toes, they're extinct today. The kinds that have the 1 toe are still around. But they're different sizes. That's okay, there are horses of different sizes today. These are both adult horses. They're just different breeds. Lots of variation built into the horse kind. What we don't see is a non-horse becoming a horse. You see, the illustrations that the evolutionists will point to in the fossil record show variation within a kind. They do not show one kind becoming another. It's just not there. If you see one kind becoming another illustrated in a textbook, it's not based on actual fossils. It comes from somebody's imagination. You'll see artist's illustration. That's all you have. What about the rocks in which these fossils are found? Don't rocks take millions of years to harden from mud? Here's a set of car keys embedded inside solid rock. I don't think that took millions of years to form. Here's a man-made clock embedded inside solid rock. That's the one rock we know right when it happened, right? What about all these rock layers? Now, not all of these are rock, but they're sediment, and some of them have turned to rock. You'd think, well, look at all that. I mean, there's a person down there for scale. Certainly those must have taken millions of years. None of those existed before 1980. They were produced in the Mount St. Helens eruption. The black layer on top was a subsequent eruption. And then it came through and cut through those layers too. Mount St. Helens demonstrated that a lot of the things that secularists take millions of years, in fact, can happen very quickly under catastrophic conditions, flood conditions. There's a nearby lake at Mount St. Helens, Spirit Lake, that was dislodged when Mount St. Helens erupted, and it cut a canyon 1/40th the scale of the Grand Canyon in a matter of days, perhaps hours. Happens quickly. These little laminations, like you'll find in the Grand Canyon, they used to say those are annual. Each one of those is a year. Add them up, millions of years. See, the Bible's wrong. Except these were actually formed in the Mount St. Helens eruption. None of those existed before 1980. They were laid down at the same time. It has to do with the way the mud flows. They're not annual layers at all. And those are the same kinds of features we find in the Tepete sandstone, which covers much of the United States and Canada. Yeah. We find trees buried vertically without roots. A little bit of coal at the base. How does that happen? Well, we know that. We know how that happens now because Mount St. Helens did it. When it erupted, it uprooted trees and deposited them in a Spirit Lake, and that's why they don't have roots, because they're pulled away from their roots by the explosion. And then they tend to float vertically because what's the little bit that's left of the roots is a little heavier, and so they get waterlogged. A few of them are on their side. It's consistent with what the Bible teaches about the worldwide flood. It's just this, Mount St. Helens was just one pitted little volcano. During the worldwide flood, the Bible says the fountains of the great deep, all the fountains of the great deep burst forth. So maybe all the underwater volcanoes going off at the same time. That's going to do a lot of damage. So you see, when we look at these rock layers and we apply good observational science, it's consistent with what we'd expect given what the Bible says about creation and a worldwide flood. It's not consistent with the millions of years view or with evolution. So when you see these rock layers, you shouldn't be thinking, well, that happened over millions of years. You should be thinking, wait a minute, this is judgment of God. The real message of the rock layers? Repent. God's a righteous God. He won't put up with sin forever. And so we need to repent of our sin and trust in Christ. Well, I could talk about this for millions of years, but let's get to the resources here. Ultimate Proof of Creation gives you a bulletproof argument for biblical creation. This is a book I wish every student would read before they go off to college. Teach you how to think rightly, how to think through the professor's arguments, and so on. We have a DVD along those same lines. Understanding Genesis. How do we know that Genesis really means what it says? Because it really does. It really does indicate God created in 6 days, and this goes through and shows you that the arguments that people try to use to get around the straightforward meaning of Genesis, they don't fly. They really don't. We have a DVD on that topic as well. His star. What about the star that guided the Magi to the Christ child? There's another DVD on this topic produced by a lawyer. I think he's a nice guy. I think he's dead wrong, though. This is going to go through and show you what I think the answer is, and biblically why it would have to be that. Discerning truth. How to spot the logical fallacies that evolutionists tend to use when they defend evolution and argue against biblical creation. Creation evangelism. How to use creation to better share the gospel with people. That's very, very useful. Dinosaurs in the Bible. Got a new Jurassic World movie coming out next weekend, I think. And so, yeah, you want to be equipped, see what the Bible has to say about that. And by the way, your kids will love that one too, because it's cool. Secret Code of Creation, I'm going to do that presentation next, but we do have that on DVD and Blu-ray if you can't stay. And we have a book on that topic as well, Secret Code of Creation. Keeping Faith in an Age of Reason answers over 400 alleged Bible contradictions. You've heard the secularists say, well, you can't trust the Bible because that verse contradicts that verse. Well, they don't. I checked. And there's the answer. Introduction to Logic. Most schools don't teach logic anymore. Most public schools don't. And I think there's a reason for that. Logic's about how to use your brain properly. And most people do not know how to use their brain properly. And so this is a great tool to use. Very useful in apologetics, but just beneficial to your life in general. Use your brain properly. If you want to use it as part of a curriculum, because I wrote this at kind of a junior high to high school level, really. But a lot of adults have never had logic, so you might want to pick it up. If you want to use it with your students, there's a teacher guide with tests and quizzes and things like that. By the way, you can get the best of our books together for 20% discount. You can get all of our DVDs together for a 20% discount, our video pack. Or you can get kind of the best of everything. This is our library pack, and it's 30% discounted. We only do that at conferences like this. So if you want to get an instant creation library, that's the way to do it. And do sign up for our free monthly newsletter, and check us out on the web, biblicalscienceinstitute.com. A lot of great free articles on that website. So thank you very much. Pastor Bill.
So we got more snacks out there, and we'll be back in here 12 o'clock, let's say 12:05. Back in here. We're working towards ending at 1 o'clock so we can have lunch together. So 12:05, be back up here. We'll start the last session.